Yes, sir. It is ready now.
Okay.
Good afternoon, all of you. I heartily welcome you in this special guest lecture session organized by Department of Botany, Adarsh Education Societies, Art, Commerce and Science College, Hingoli. I heartily welcome on this occasion Principal Dr. A.R.Marathe sir as a chairperson of this session. I again welcome our guest speaker, Dr. V.R.Marathe sir, on this occasion. Along with, I welcome Dr. N.E.S. sir, in charge principal, Adarsh Mahila College, Hingoli. I welcome Dr. V.R.Marathe sir, Dr. Deshmukh sir, my teachers, friends, colleague, senior teacher staff, and my dear students. It is a privilege to me to get this activity organized by the Department of Botany. Today we are going to getting a very fruitful information from this lecture. That is one of the important topic belongs to plant taxonomy, and that is ICN, International Code of Nomenclature, principles and rules. So with this, I am going to introduce, firstly, I am going to ask for the to say a few words on this occasion to respected Dr. A.R.Marathe sir, chairperson of this session. Dr. Marathe sir, please say a few words on this occasion.
Thank you. Good afternoon, all of you. Here I welcome guest lecturer or guest speaker, Dr. V.R.Marathe, Dr. Nagarkar, HOD, Department of Botany, Adarsh College, Hingoli, Dr. Nanded, Associate Professor and the in-charge principal of Mahila College, Dr. Pratap Deshmukh, the Nagnat College. Our botany department remains always ahead to take the various activities of this type. Previously, one of the guest lecture is arranged by this department, and always it remains ahead in our college. Our best wishes for your guest lecture to all of you. Thank you very much.
Thank you, sir. Your words are always encouraging us to organize such activities. I am very much thankful to you, sir, for your benign presence. Now, let me introduce our chief guest speaker today, that is Dr. V.R.Marathe, sir. Dr. V.R.Marathe, sir, he is assistant professor in PG Department of Botany, Nanded Education Societies, Science College, Nanded. He done his MSc and PhD in Botany with SET in Life Science with the specialization Taxonomy of Angiosperm, Phytochemistry and Pharmacognosy, and Ethnobotany. He has 15 years of UG and PG experience, and he is also recognized research guide of SRTM University Nanded. He has undertaken 4 PhD students and near about 47 MSc dissertations he has been guided. He has been published 33 national and international papers. He has also received the Google Scholar Citation Index to this H Index and I-10 Index also. He has published 2 books and undertaken 2 minor projects. He has been organized 7 different national and international conferences. He has been presented a paper in various conferences. Near about 31 papers he has been presented. He has been attended several different conferences. He has also delivered guest lectures, various guest lecture at various institutions. He has been delivered talk at different national conferences, seminars, workshop, and he has been chaired also several sessions. He is a recognized research guide in botany in SRTMU under SRTMU Nanded. He is a recognized PG teacher. He is associate editor of International Journal of Life Science. He is also coordinator of PhD coursework at his research center. He is life member of Indian Association of Angiosperm Taxonomy, also Indian Science Congress Association, Kolkata. He is also life member of Marathwada Botanical Society, Aurangabad. He is also life member of Nanded Education Society, Nanded. He has worked as an invitee member in BOS in construction and restructuring of the syllabus under in SRTM University Nanded. He is the professor in charge of MSc Herbal Medicine. He is invitee member of BOS Biotechnology, BO training in SRTM in Nanded. He has been contributed lots of work in examination, paper setting, work as a SES. Then along with, he has been contributed lots of to the college committees. In various committee, he has been acted as a role, IQC committee, NAC committee, UGC committee, NIRF, NET committee, campus development committee, science association committee, contribution to teacher, contribution to particular teacher related work, co-curricular work. He has been also there. He organized botanical study tours, PG for the PG and UG students, organized poster competitions like Avishkar and seminar and science exhibition. He has been also delivered NET guidance, remedial coaching, N.S workshop, work as a judge in regional level science exhibition, and he is also working under the consultancy services free of cost for providing identification of angiospermic plant to students and farmers. Along with, he has been supporting the farmer for cultivation, maintenance, and marketing of the medicinal plant. So such a huge biodata is in front of us, and we are going to get listening to such huge personality today. So without wasting time, I am going to invite Dr. V.R.Marathe sir to deliver his speech on ICN principles and rules. Dr. Marathe sir.
Okay. Thank you, Dr. Nagarkar sir. Firstly, I am very much thankful to respected Dr. Hello.
Yes, yes.
Am I audible?
Yes, sir. Yes, sir.
Okay, okay. So, firstly, I am very much thankful to Dr. Lathi sir, who has given me an opportunity to deliver my lecture in your esteemed institute. I am also thankful, Principal Dr. Solanke sir. I am also thankful to Dr. S.S. Nagarkar sir. Again, in the audience, certain respected teachers of Swami Ramanand Marathwada University, Dr. Anand Wagmare sir, Dr. Pratap Deshmukh sir, and certain my friends from N.E.S Amravati University, Dr. Monali Gurde, Dr. Ninad Dharkar, and many more, and all dear participants. I am delivering today a guest lecture on the topic ICN. So firstly, I will share my screen. I think Nagarkar
yes,
sir, please.
Yes, you are already allowed, sir. Yes.
Okay. No, you have disabled screen sharing. Please make me co-host. Okay, thank you. Is it visible, sir? Screen? Nagarkar sir.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, right, sir.
Okay.
Make it full screen, sir.
Okay, okay. So, dear participants, today I am going to deliver a guest lecture on International Code of Botanical Nomenclature for Algae, Fungi, and Plants. Actually, it is one of the important topic, particularly when I deliver this topic, particularly for BSc first year student, the student of Swami Ramanand Marathwada University, Nanded. As your BSc first year, semester second, fourth paper is totally related with taxonomy of angiosperm, and your unit first is related with the principle and rules of ICN. So I'm mainly focusing my today's talk with respect to BSc first year, the syllabus which is included in SRTMU Nanded University. So let's we start with this topic. So before going to detail with ICN, firstly, we are dealing with the taxonomy. What exactly meaning of a taxonomy? Actually, you know that taxonomy is one of the important subject, and it is mainly the study of classification of organism. Particularly, the plant taxonomy deal with the study of classification of plants. But there are three basic components of a taxonomy. Apart from the classification, it also deal with identification. It also deals with the nomenclature. So in this lecture, we are mainly dealing here within this nomenclature aspect. So what exactly is the meaning of a nomenclature, and why this nomenclature is important? As you know that the famous quote of Shakespeare, what is in a name? Actually, name, it is very, very important. But why this name is important with respect to the plants? We know that in human beings, we have our naming system, and we have a unique name. But what about the plants, and what exactly the phenomenon, rules, and regulations which are related with the nomenclature of a plants, we will deal here in this lecture. So nomenclature is just a process of naming of a plants based on certain international rules agreed by botanists in order to ensure a stable and uniform system. So whenever we want to name the plants, it is mainly based on certain rules which are governed by the botanist of the world. So it is actually an international agreement of a botanist, so that these rules, they must be important and they are unique throughout the world. So this process of naming of a plant, it is nothing but a nomenclature. So in short, nomenclature is nothing but an art of giving name to the plant. Why this nomenclature is important? It is important aid of a communication, because when we want to communicate with each other, or when we want to deal with certain plant species, we have to the name is very, very important. So it is one of the important aid for the communication. Again, it is important to denote relationship among the taxa. When we compare two different taxa or more taxa, or when we are dealing with any medicinal plants, when we are talking about its characters, which medicinal properties, so the to denote the relationships within that particular taxa from different localities or from the same localities, we have nomenclature is very, very important. So for that purpose, for the communication and for the denoting the relationships, nomenclature is important. Again, there are various naming systems are there. Particularly, the common names are there. The common names are very common. They are also commonly called as local names or vernacular names. This makes things extremely difficult and may create confusion. Actually, the usage of these common names, they are very smaller usage, because you know that when we are talking about our naming system, we have our common names in our homes or relatives, and this common name is very restricted in use. We are using that common name in our relatives, within our family members, or it may be related with our colony only. So apart from that colony, apart from our relatives, we don't know about any other person apart from our family or relatives with our common names. So these common names, they are very smaller usage, and that's why it is misleading or inadequate if we want to communicate at a broader area. So they are not important, and so if you want to deal with any other area apart from our relatives or apart from our known language, this may create confusion, or they may be misleading or inadequate, and this makes thing extremely difficult and may create confusion. And for that purpose, these common names, they are not used for the scientific purpose. Actually, not all the plants, when you are talking about the plants, most of the plants, they also do not have the common names, because we are giving common names to such a plants which are economically important for us. And there are a lot of plants which we don't know exactly their economic importance, their medicinal values. So for such plants, we are not having the common names. So these common names, they are not available for all the species which are resided on the earth. So again, it may be changed according to language and dialect to dialect. As you know that when we are talking about our Indian perspectives, in India there are various states are there, and each state has its own language. And when the state has been changed, the language has been changed, the names are also get changed. When we are talking about the Maharashtra, in Maharashtra we are just our mother tongue is Marathi, but it has certain dialects, Boli Bhasha. There are different dialects which are present within the Maharashtra or in Marathi. So these dialects are changed every after 20 miles, and naturally these dialects, they are having their own words, they are having their own names of plants within that particular language. So thus, the particular plant may have several names within a country, within a state, or even within a particular geographical area. So, for example, mango has more than 50 names only within the Sanskrit language. For example, Brahmi, which is very important medicinal plant, which is mainly used in Brahmi Aula Kestel. I think you might be seen this the ad of this Brahmi Aula Kestel on television. That Brahmi, it is one of the important medicinal plant, and it is known by 3 different known species. That is, it is that Brahmi common name has been given to the Bacopa monnieri, Centella asiatica, and Viola indica. So actually, which exactly the Brahmi, which has medicinal value, it is very difficult to judge, and that is the difficulties which arises due to the common names. Again, all the plants which yields milky latex, as you know that in our surroundings there are a lot of plants which yields the milky latex. We commonly call them as a dudhi. So if we are not know the scientific names, all these plants, they are having the same name, that because of the same character, that is they yield the milky latex, naturally they are commonly called as dudhi. Again, for example, banana is known by the name Kela in Hindi, Vajapujam in Tamil, Arati in Telugu, Itavala in Malayalam, Balle in Kannada, and Kola in Bengali. So, if we are using common names, it leads misleading, or it is inadequate. So what is the purpose of a nomenclature? It is one of the important aid of a communication, and it also serves as a denoting relationships among the taxa. Our purpose of a naming of a plant is not completed, and that's why because of certain disadvantages which are arises due to common names, the scientists, they are shifted to the scientific names. So what exactly the scientific names are there? So scientific names, they are the having very huge usage because these names, they are only single name, and they are with an international usage, and so helps in international communication. They may not change according to language and language to language and dialect to language, because they are given in Latin language, or they may be Latinized so that they are unique to the world. It may be proved truthful and adequate for the wider use. So as the single name is used for throughout the world, so naturally it is very important to communicate at any corner of the world, and also have important parameter while deciphering the characteristic feature of any particular plant, and we can easily recognize the relationships among the taxa by just using the scientific names. Say for example, mango is known by Mangifera indica throughout the world, because this Mangifera indica, it is a botanical name which is used throughout the world, and it is a correct and unique name which is scientific name of this plant. There are certain advantages of these scientific names are actually they are unique, they are understood and followed throughout the world, and they are not changed easily. they are the scientific names provided are often descriptive and also indicate some important characteristics of the organism. But apart from there, they are having certain disadvantages. For example, the important disadvantage of this scientific name is they are Latinizing. So actually these plants names are in either in Latin language or they may be converted into the Latinized form. So these names are not remembered by most of the student, and that's why they fear about the taxonomy, because most of the student they are not comfortable with the taxonomy. It is only because of the names which are not recited by them, because these names they are very very difficult, and whatever the, for example, mango, it is written as a Mangifera indica, and it is somewhat difficult to understand. It is somewhat difficult to recite them. So, but apart from this, there are greater advantages are there, because these names they are unique and they are very much important. Apart then in scientific language, when we are talking about Linnaeus, Carolus Linnaeus, who has honorably called as father of botany, who was first author who has continuously using the binomial nomenclature in his classification system. But before to that, the taxonomist, including Linnaeus, before 1753, most of the scientists they are using polynomial nomenclature, as these polynomial these scientific names they are somewhat difficult to understand, somewhat difficult to recite. So they are using polynomial nomenclature. This polynomial nomenclature, polynomial actually, polynomial includes poly means many, nominal means names, the name which includes many names within it. So such Latin names were mostly taken from common name for the sake of precision, but they had to supplement it by the adjectives. Means actually this name is mainly derived from the common names, and they are supplemented by a certain characteristic feature of that particular plant, and such a name which is formed there, which includes generic name which is associated with the very few or many adjective words revealing the diagnostic character of a plant, to exact identification of plants. Actually, this polynomial nomenclature system is mainly advocated by the scientist just for the correct identification of a plant. But as these names they are very longer and they are having many words within them, so they are also difficult to understand. They are also difficult to recite them. So say for example, Sida acuta, which is a binomial nomenclature to very common plant which is present within our area. It is known by its polynomial name Althea coromandelina angustis prolongis foliis semine bicarnio. So friends, you know that when we are face difficulties to remember this Sida acuta, two names only. So you just imagine how difficult to understand and to remember this entire polynomial name. And if the plants they are very smaller in number, and we might remember all these names. But after Darwin's classification, after Linnaeus classification system, most of the scientists they are mainly work within the taxonomy, and most of the plants they are identified, and naturally up to this condition there are a lot of plants they are identified. So it is not possible for anyone to remember, recognize this polynomial nomenclature. So and it is also very difficult because certain names they may having very longer supplemented adjectives along with the genus, and that's why such idea has been dropped by most of the scientists after the Linnaeus classification system. So again, after that, because of certain difficulties which are arises due to the polynomial nomenclature, the next type of nomenclature has been arises, that is binomial nomenclature system. Actually, it is a very simple naming system which includes only two names, that is naming of a plants by two names, which includes the generic name and specific epithet. Actually, this concept was first time introduced by Caspar Bohin. It is not actually introduced by Linnaeus for the first time. It is introduced by the Caspar Bohin. but he has not consistently used his this binomial nomenclature in his own classification system. But the Linnaeus was the first scientist who has used that concept in his classification system in 1753 in a book, Species Planctarum. Actually, this book, it is very, very important, and this book and this date, when 1st May 1753, is considered as a starting point of a nomenclature or taxonomy. So this Linnaeus was the first scientist who has used this binomial nomenclature along with the polynomial nomenclature. So when he has used both naming system in his classification system, so that most of the scientists, they recognize how the binomial nomenclature, they are very easier than that of the polynomial nomenclature, and that's why this classification system was so famous, and most of the scientists, they are attracted towards the identification and nomenclature of plants. Actually, binomial nomenclature, there are certain rules are there which are very known to you. For example, genus is the first name of a plant, and it is always and always noun. Species follows the next, and it is often adjective. These names should be in Latin language, or it may be derived from any language, but it should be in a Latinized form. Genus name should be capitalized, and species name should be in a small letter. And when we are type these names, it should be in an italics font, or it may, if we write these names, we should separately underline these two words, that is species and genus. So these are the certain important aspect about the binomial nomenclature. Now, what are the actually advantages of these binomial nomenclatures? Actually, binomial nomenclature are universal names for the plants. They are definite and precise. They are very smaller. They are precise, and that's why they are very easier to remember. They are, again, they describe the main feature of the plants. Whatever the phrases which are included within them, they directly has meaning with their certain important character of a plant. Again, these names either in Latin or Greek, and they are easy to arrange plants based on their systematic relationships, and so that whatever the important aspect of a nomenclature, that is, they are mostly utilized for the communication of plants, and they are also denoting for the relationships among the taxa. So all these aspects, they are governed by this binomial nomenclature. So that's why these binomial nomenclatures, they are used mostly after the Linnaeus in botanical nomenclature. As this Carolus Linnaeus is considered as the father of taxonomy, and he was the very important scientist, because nomenclature, whatever we are dealing today's nomenclature or ICBN or ICN, it is mainly started with the Linnaeus. Actually, our today's topic is the International Code for a Botanical Nomenclature. Actually, this nomenclature involves the principle governed by the rules and formulated and adopted by the International Botanical Congress. So the question is that why the rules there arises, or why there is a need to formulate certain type of rules, and why these rules they are adopted by International Botanical Congress, and all these parameters are there. So what exactly the rules are there, and why there is a need of these rules? Just we see how the this concept has been arises, how the scientists they are thought that this nomenclature code must be there to regulate the entire nomenclature system within the plants. So in today's concept, that ICN, actually most of the student, they might be thought about ICN, because you might be heard about ICBN. Actually, International Code for Botanical Nomenclature has been changed. That name has been changed to ICN in International Botanical Congress, which is held at Melbourne in 2011. So after 2011, this ICBN has been changed to ICN, that is only International Code for Nomenclature of Plants. The International Code for Botanical, International Code of Nomenclature of Algae, Fungi, and Plants, it is considered as a ICN, is the set of rules and recommendations that govern the scientific naming of all organisms traditionally treated as algae, fungi, and plants, whether fossil or non-fossil. So it also includes fossil and as well as non-fossil plant groups. So here in this lecture, we are mainly deal with whatever the rules which are included in your syllabus and the principles which are included in a ICN, International Code of Nomenclature for Algae, Fungi and Plants. So before going to detail with that, we have certain look around the history that why there is a need of a ICN or ICBN, why there is a need of a code of a nomenclature. So before middle of 18th century, the names of plants were polynomial, consisting of several words, as we have already seen. And for the first time, Linnaeus thought that these names, they are certain misleading. These names, they are very difficult to remember. So whatever the concept by which we are shifted from common names to the scientific names, that our criteria has also not fulfilling our concept or not fulfill our aspect regarding the characteristic feature of a plants or communication and denoting relationship among the organisms. So Linnaeus proposed elementary rules. So for the first time, Linnaeus was the first scientist who has proposed elementary rules, means basic rules, in his book Philosophia Botanica in 1751, before his classification system, which is published in 1753. So he has given certain basic or elementary rules how the plant's name should be. Such rules are governed by the Linnaeus. After Linnaeus classification system, that is which is published in Species Planctarum on 1st May 1753. His classification system was so famous. It was so famous that most of the scientists or most of the workers from the different fields, means the scientists from physics, scientists from mathematics, scientists from chemistry, they are attracted towards the botany, and all they are shifted to the study of plants. And that's why what happens, most of the scientists influenced by the work of Linnaeus and explore new parts of the world for the identification and naming of a plant. And everyone tries for the new areas, everyone goes within the new areas, explore that particular areas and giving name to that particular plant. Whatever the names they want to give that particular plants, they give the names. So there is no specific criteria, there is no specific rules at that time for the naming of a plants. And so after 1753 to the 1813, so for the first time in 1813, A.P.D. Candle, he was again one of the important scientists, who has thought that how much plants they are identified, we have to judge how much plants they are identified throughout the world and what are the names which are given to that particular plant. So for that purpose, he has again he has thought that there are certain rules must be there for the naming of a plants, and he has given certain details rules regarding the plant nomenclature in his book entitled Theorie Élémentaire de la Botanique. Such books they are published, and he has given certain rules regarding the plant nomenclature. So there are two scientists who has proposed the rules of a plant nomenclature, Linnaeus and A.P.D. Candle. And the son of A.P.D. Candle, that is Alphonse de Candolle, in 1867, who has organized a meeting of all botanists of the world, throughout world, to discuss about the rules and what are the disadvantages which are created or discomfort which are created because of the common names. What happens because of most of the scientists, they are work within the botany. Suppose I am working in Nanded and I have got certain new plant. I have given my name to that particular plant. You are working in Hingoli and you got certain new plant there. Same plant which is identified by me, it is same plant which is identified by you also, but I am giving the different name to that particular plant and you are also giving a different name to that particular plant. That is the one case. In another case, what happens? Means a plant is same but names are different. In another case, whatever the name I have given to that plant, the same name has been given to the plant by you, but the plant is different. Means after Linnaeus and up to the 1867, there are possibly two conditions will be arises because of there is no specific rules for the nomenclature. So the plant is single and the names are different, or the name is same or the plants are different. So and that's why it is not a unique. So for what purpose scientific naming system has been arises or has been accepted by the scientist? It is only because of a unique name throughout the world, and which is not create miscomfort, misleading throughout the world. It may be important aid for the communication, that should not be there. And the same plants has multiple numbers, names are there. So for that purpose, Alphonse de Candolle has decided that we have to organize all the botanists on a single platform, and he has organized first International Botanical Congress in 1867. And this first International Botanical Congress was held at Paris. And this code, or the whatever the rules are, they are decided in that particular Congress, they are considered as a Paris Code. So after that, there are certain in 1930, Fifth International Botanical Congress was held in England to frame rules and regulation of naming of plants. In 1975, 12th meeting was held in Leningrad, USSR. Actually, this International Botanical Congress is very much important, which is organized in July 1975. So whatever we are studied today, ICBN, International Botany Code for Code of Botanical Nomenclature, or ICN, the basic structure, it is accepted within the Leningrad Botanical Congress. So based on this resolution, the existing system of International Code of Botanical Nomenclature, ICBN, was adopted from 1978, but actually it is passed in 1975. So whatever the three rules, three divisions which are present within the ICBN, that is first division includes set of 6 principles, then second division includes various rules, and third division includes recommendations. All these things are there. They are only because of this Leningrad International Botanical Congress. Again, IBC, actually International Botanical Congress, meets every 5 to 6 years to decide any additions or change within the naming and numbering of plants. And the recent ones are there. 18th IBC Congress was held at Melbourne in 2011, where the name change of ICBN to ICN was effected. So this Melbourne International Botanical Congress is also very much important, because here the entire name of a International Code for Botanical Nomenclature has been changed to ICN, International Code of Nomenclature. And the latest International Botanical Congress is held at Shenzhen in China in July 2017. So whatever the new rules are there and all these parameters are there, we are dealing here with according to the Shenzhen 2017 code. It is also commonly called as Shenzhen code, the basic structure. But actually it is only here there are certain changes which are occurred, but the basic structure which is studied, it is according to the Leningrad USSR Congress. So that Leningrad code, it is having the basic structure of a ICBN, which is still we are in use. So let's we start with the today's topic and whatever the important aspect regarding the International Code of Nomenclature for algae, fungi, and plants. So the to formulate such code, actually there are basic aims according for the formulation of this code. The first important first important aim of ICN is that to provide unique and correct name which is universally accepted. So the basic aspect and the basic aim of this ICN is to provide unique and only one correct name. Again, to provide stable method of nomenclature, to avoid and reject the names which cause confusion, and to avoid useless creation of names. So these are the certain aims of ICN. But the basic aim is to provide unique and correct name. Now, this ICN or International Code of Nomenclature, its outline is having certain important aspect. This code has been divided into 3 different divisions. Division first is includes set of 6 principles. Division second, which includes rules and recommendation, and division third, which includes provisions for the governance of the code. Actually, this basic structure, it is accepted within a Leningrad conference, and likewise still it is still in use. So in this ICBN or ICN, actually it has three different actually divisions. Division first, which includes set of six principles, they are also included in your syllabus. In division second, certain rules, there are various rules, and there are various under various articles are there, and there are certain recommendations are also there. So in your syllabus, typification, rank of taxa, and author citation, these three major rules they are included. And division third, which includes certain provisions of governance of the code. There are 8 provisions are there. Apart from this, after the code, there is a glossary of a definition of terms used in this code, and there are 7 appendices are there. Actually, ICBN includes only 3 appendices, but here in this case ICN includes there are 7 appendices actually given as a supplement along with the this code. So these are the list of the conserved and rejected or accepted names of a families, names of a genera, names of a species, certain suppressed names, certain hybrid names, and all these parameters are there. They are actually in the appendices. So firstly, we are so here there are certain rules. Division second includes, these are the various chapters which are included there. These chapters again divided into various sections, and these sections they are include certain articles, and every article is mainly coded for the specific rules are there. So firstly, we are dealing here with the division first, which includes set of 6 principles. So this is a very important topic of your syllabus because it is included in your syllabus, and most of the times the questions will be asked on examination within the principles of ICN. So let's we start with principles of ICN. The nomenclature, the first principle of ICN, there are actually set of 6 principles are there. So the first principle of ICN, it is stated for the nomenclature of algae, fungi, and plants is independent of zoological and prokaryotic nomenclature. Means whatever the rules and regulations which are included within this code, particularly for the nomenclature of algae, fungi, and plants, they are totally independent of a zoological and prokaryotic nomenclatures. So it is also commonly called as independent principles, or it is also commonly called as straightforward principle. So why it is independent? Because the name of an animal and plant may be similar. There may be a chances that the names should be they may be similar within both groups, that is of a plants or animals. For example, here if you see here in this diagram, this is a diagram photograph of a Cecropia moth. The genus name is Cecropia, and here the tree also has the same genus name, that is Cecropia. So both, this means of a zoological nomenclature it includes the same name, and in botanical nomenclature it is also include the same name. So it is independent. They might be same, or they might be not same. So their rules are different, our rules are different. For our rules are only for the plants. So but only one case is that in plants the repetition has not been accepted. Again, another important parameter according to this first principle, that tautonyms, they are not accepted here. Means actually tautonyms in which the specific epithet and the generic name are identical in spelling is not a valid, while it is permitted in ICZ, zoological nomenclature, it is permitted, but it is not permitted by the ICN. For example, Naja, which is zoological name of a Indian cobra, Rattus, which is zoological name of a black rat. But in botany also there are certain names which are just like that, but they are not a tautonym. Tautonym means the generic name and specific name, they are having the same spelling. Means here Naja, genus name Naja, and species name Naja, means it is a tautonym. But here in botanical nomenclature, Kajan is there. Tur, the botanical name of a tur or pigeon pea is a Kajan. So, but here it is not a tautonym because spellings are different. Bambusa, Bambos, it is also not a tautonym because the spellings are different. So for the various animals and bacteria, the different codes are there. So different codes of nomenclature, for example, international code for what nomenclature of cultivated plants, means whatever the ICN is work here, it is only for the wild plants. It is not for the cultivated plants. So for the cultivated plants, there is another international code is working there, and the name of that particular code is International Code for Nomenclature of a Cultivated Plant, ICNCP, which is only for the cultivated plants. Then International Code of Zoological Nomenclature for the animals, International Code of Nomenclature of Bacteria. Bacteria, they are having their own different code. International Committee on Taxonomy of Viruses, ICTV, for the viruses. So these are the different codes. And here, in this case, we are only focusing, or we are mainly govern the rules regarding the nomenclature for algae, fungi, and plants only. So it is totally independent that of the zoological and prokaryote nomenclature. Then second principle, it is also very, very important. The second principle stated that the application of a name of a taxonomy group is determined by means of a nomenclature type. So this nomenclature type is important. So what is meant by the nomenclature type? Actually, nomenclature type, it is either a specimen, either illustration, either a photograph, either a diagram, or any material to which the name is permanently attached. So nomenclature type is a specimen or illustration to which validly published name of a taxon is permanently attached, is called as nomenclature type. Actually, usually it is a herbarium specimen, and it also acts as a standard for solving taxonomic problems. Say, for example, when we are talking about any particular plant, you might be known about, we have already given the name that mango has the botanical name Mangifera indica. You might have question that why this mango is called as Mangifera indica, why it is not called as Azarrecta indica, why it is not called as Cocos nucifera. It is because the herbarium specimen which is deposited within the Kew Botanical Garden as a nomenclature type, it has same character which are present in the mango which is available in our area. So that's why the name has been given to that mango plant as a Mangifera indica. So it also acting as a standard for solving taxonomic problems. Again, from 1958, the time must be designated for family or below ranks. The type of Brassicaceae is the name of a genus name, that is Brassica. So there are a lot of families are there which are having older names and new names, because the rules, they are directly governed that if you want to given the name of a particular family, it should be on the name of a genus. So Brassicaceae, actually the older name of a Brassicaceae family, it is a Cruciferae, because on the basis of crucifer type of corolla. But the new name is that Brassicaceae on the basis of Brassica genus. So this nomenclature type, it is very much important. This nomenclature type, or naming or deciding the nomenclature type, there are certain rules. We will deal that particular rules within the typification or type method in detail in a rules section. So you must remember the name, that application of name of a taxonomy group is determined by means of a nomenclature type. The third is related with the nomenclature of a taxonomy group is based upon priority of publication. So the priority has been given to the publication whose publication is earlier in date. If two or more names apply to the same taxon at the same taxonomic rank, the earliest legitimate name has priority and is a correct name. Say, for example, I am giving you certain the example that if I have identified one new plant here in Nanded, and you have identified a new plant in Hingoli, the same plant is there. Both we are having identified the same plant, but at different localities. I have published that name, you are also published that name accordance with the rules and all these things. But whose name has been accepted by the ICBN? So for that purpose, there is no bias, as I am a teacher and you are the student. So there is a bias that teacher is correct, and so that whatever the name I have suggested, that will be accepted there. But so such no bias will be there, and for that purpose, this priority of publication is very much important. So in that, whatever may be the rank or position or any particular name which is given, it should be published, and it, if it is published legitimately, it should be accepted, and whichever the publication date is earlier, that will be accepted as a correct name. So while giving you the synonyms, say for example, Catharanthus rugius and Vinca rugia, these are the synonym of a same plants. So which one is the correct one? So you have to just find out the priority of publication, whose name is published firstly. Catharanthus rugius is the correct name, and Vinca rugia is the synonym of that particular plant. Because of the we are applying the principle of a priority here. So from 1st May 1753, which is considered as the starting point of a nomenclature, after whatever the names which are published after that date should always and always follow the principle of priority. No names published before this date are considered to be validly published. So before 1753, if the names they are published, they should be validly published after this date, and they are not accepted as a validly published name. Not applicable for the suprafamilial names. For example, ranks above the family. This principle has not been applicable there. Fourth principle is related with each taxonomy group with a particular circumscription, position, and rank can bear only one correct name, the earliest that is in accordance with the rules, except in specific cases. So, any taxonomic rank, whatever may be its position, whatever may be its circumscription, outlying it, whatever it may be very bigger tax rank, or it may be present at a higher taxa or a higher rank, or it may be present at a lower category. It is name of a higher category or lower category, or it may be having different position, whatever may be the case, but it may can bear only one correct name. So the correct name, and that should be only one. So that unique name is advocated by this principle. So and whatever the unique name has been or correct name has been accepted, which is earliest in the accordance with the rules, that should be accepted according to this principle. So the principle 4 is mainly related with the only one correct name. Then fifth principle, the scientific names of a taxonomy groups are treated as Latin regardless of their derivation. So whatever may be the names which are given to the plants, they might be you might be given the name in Marathi language, in Sanskrit language. You might given your own name. You might given the name of a region. You might be given a name on the basis of a river, or whatever may be the case. But what the name should be in a Latinized form, should be treated as a Latin. So the scientific names of a taxonomy group are treated as like a Latin regardless of their derivation. Say for example, I am giving you certain example. Putranjiva roxburghi. Actually, Putranjiva, it is a name which is comes from the Sanskrit word. And Roxburghi, the scientist Roxburgh, Williams Roxburgh, on which the name has been given. So these names, they should be Latinized. So Putranjiv, and when it is treated as Latin, it becomes Putranjiva. Roxburgh has been converted into the Roxburghi. Likewise, Bohemia, Purpurea, Caspar Bohin, on the name of a Caspar Bohin, the name has been given to Bohemia. Purpurea means actually it is converted into the Latin. Then Simpela marathwadensis. Actually, this name is of a algae diatom, which is mainly present within the Marathwada region, and that's why the name has been given to this diatom Simpela as a marathwadensis. So Marathwada has been converted into Latinized form as a marathwadensis. But the question will be there, why this Latin language has been used for the scientific names and all these parameters? Because it is a dead language. Because nowadays it is not spoken in any country, and that's why there is no bias of any country on this language. So it is not an official language of any country. So most of the Europe, and again another important parameter is that most of the European languages, they are derived from this Latin, and it is also widely used by the scholar in an ancient time before 1815 AD in European countries, and most of the botanical literature, most of the scientific literature has been written in a Latin language. Apart from that, this language is so comprehensive because it has much more phrases with a specific and exact meaning, so that whatever the number of plants, if they are also increases, if we are identify more and more plants, the phrases they are available for naming new plants within this particular language. Again, the grammatical sense of the word is also commonly obvious. For example, white translated as album as a neuter, alba as a feminine, or albus as a masculine, means this language is somewhat elastic language, and it may be translated very easily in different phrases, and that's why grammatical sense of this language is also very much important. So that's why, because of certain reasons, this Latin language has been used as a scientific language, particularly for the naming of plants. The rules of nomenclature are retroactive unless expressly invited. Means, no doubt, this actually this code has been uh, established in 1867, because the first International Botanical Congress is held at Paris uh, by Alphonse de Candolle, and through from that Paris Code, the various rules and regulations are accepted. But whatever the names which are suggested before that 1867, so that's why this principle has been introduced here, that the rules of nomenclature, they are retroactive, means they are they are applicable before 1867 also. So the just priority is retroactive to the 1st May, means from 1st May 1753 to the 1867. So whatever the names which are given in between that particular period, they must follow the rules, either they are rejected by the ICBN. So this is again another important rule of a or principle of a ICBN. So these are the 7 principles are ICN. Now we are switch over to the next division, that's division 2nd, which includes various rules and recommendations. And here in this case, there are 3 rules which are included in your syllabus, that is major rules of ICN. The first section or chapter 1st, which include taxa and their ranks. This article 1st to 5, they are coded for this taxonomic rank. It is also commonly called as taxonomic rank or rank of a taxa. So you have to remember article 1 to 5, because these articles, they are mainly related with the rules and regulations which are governed for the taxonomic rank. So there may be MCQs will be asked in examination which articles they are coded for the taxonomic rank. So you have to remember all these 1 to 5 articles. So what is meant by taxonomic rank is there. So taxonomic rank taxonomic rank actually it is just if you understand the taxonomic rank, you have to know about 3 different aspects: rank, category, and taxon. So what is meant by rank, what is meant by category, and what is meant by taxon? Actually, taxonomic rank, actually it is a hierarchical levels. Category, it is a artificial concept to which plants they are categorized, and taxon is nothing but a living organism which are actually categorized under the category. So these are the 3 different aspects, but most of the student, they may be considered these 3 terms as a synonymous term, but actually these are not the synonymous terms. Taxonomic rank, actually rank denotes the position where actually that category is there. Category, it is actually the artificial compilation of a plant groups. So category includes either a genus, family, division, species, and all these things. And taxon includes actual organisms which are organized under the category. So taxonomic rank is an abstract term used in a scientific classification of organism. When we are want to classify the organisms, we are using certain hierarchical levels, and these hierarchical levels, they are having certain taxonomic ranks. So the taxonomic ranks indicates the level of a taxon in the taxonomic hierarchy. Taxa rank at a particular taxonomic rank are grouping of organisms at the same classification level. So taxon is the taxonomic group of plants of any rank. For example, hibiscus, which is a genus, Malvaceae, which is a family. Actually, Malvaceae is a taxon, and family, it is a category. And position, when we denote the position of this Malvaceae, means family, it is comes under the order, and it is just above the genus level. So that position is denoted by the rank. So in the hierarchical level. So these are the three different aspects about the rank, category, and taxon. Actually, the rules of nomenclature prescribe categories for the classification, and whatever the rules which are there related with the nomenclature categories or rank or taxon, they are totally related here in article 1 to 5. These categories constitute the basic unit of a classification, and the basic unit of a classification is a species. So there are various categories, there are ranges, they are substituted, they are created by the ICN for the classification purpose. So there are certain articles, how and where they are coded for. So the article first is coded for the taxonomic group at any rank will in this code be referred as a taxa, singular term taxon. Means whatever the taxonomic group is coded by any rank, it must be considered as a taxa or taxon. Article 2 stated that every individual organism is treated as a belonging to an indefinite number of taxa or constitutively subordinate rank, among which the rank species is a basic. There are a lot of categories that are decided, but the basic category is always and always a basic category. And this article 3 and article 4, they are also very much important, because again the MCQs will be asked in examination on these two articles. According to ICN, there are certain principal ranks are there. Actually, according to ICN, there are 24 categories they are decided, out of which certain principal categories there, certain secondary categories are there, and certain subcategories are there. So what are the principal categories are there? So the question will be asked in examination that which of the following is a principal rank of a taxa according to ICN, and there might be certain choices will be there. So the principal rank of a taxa is descending sequence. For example, kingdom, it is a principal rank. Division or phylum, which is also a principal rank. Then class, order, family, genus, and species. So these are the 7 ranks are there, which are considered to be as a principal rank. Particularly kingdom, kingdom plantae. According to Bentham and Hooker's classification system, kingdom plantae, he has used that term kingdom. Most of the times division, which is used here, Bryophyta, Pteridophyta, these are the divisions. And phylum, particularly phylum, we are not using most of the time, but this phylum is a equivalent term which is used by the ICBN or ICN with respect to the division. Then class, order, family, genus, and species. These are the principal rank of a taxa. Then article 4, which includes secondary rank of a taxa. So these are the principal rank, and which are coded by the article 3, and article 4, which are coded the secondary rank of taxa. Say for example, tribe, which is present in between the family and genus. Actually, this tribe category has been decided by the ICN in between family and genus. Section and series in between genus and species. Variety and forms below the species level. So these are the 5 ranks are there, which are considered to be as a secondary ranks. And the article 5th is the relative order of these ranks specified in article 3 and 4 must not be altered. Means whatever the rank position are there, or descending or ascending sequence is there, it should not be altered in any case. If you want to use these text ranks, you should be use these ranks in a same manner, whatever which are given by the ICN. So these are the certain articles which are mainly responsible for what. Now, Again, in ICN, according to ICN, there are 24 categories are there, or 24 ranks are there. And these ranks, they might be divided into two major groups, major categories and minor categories. They are also commonly called as major taxa or minor taxa. So the minor taxa are those which are directly involved in the name of a plant. Say, for example, genus, and below the categories of a genus means genus, species, series, section, variety, subvariety, form, subform. All these uh, are commonly called as minor categories. But the categories which are above the genus level, they are considered as the major categories. And these major categories, they are not the part of a actual part of a plant. And these major categories, they are having a specific endings. Minor categories, they doesn't have the specific endings. Major categories, they are having a specific ending. So just we look how many categories are there. And all these categories, they might be converted, or they might be subdivided by the subdivisions. Say, for example, kingdom, subkingdom, division, subdivision, class, subclass, order, suborder, family, subfamily, tribe, subtribe, genus, subgenus, section, subsection, series, subseries, species, subspecies, variety, subvariety, form, subform. So there are 24 categories which are given by the ICN. And these major categories, they are having the specific endings. Minor categories, they are not having specific endings. So what are the specific endings, and how they are included within these categories? Kingdom, they are not also having the specific ending. You might use various endings for that, means plenty. Division, having specific ending phyta. Sub division, phytina. Class, Opsida. Subclass, IDAE. So you have to remember all these specific endings of a major categories, because again the question will be asked in examination on the basis of these specific ending of a taxa. Superorder INAE, then order ALES, suborder INEAE, family ACEAE, subfamily OIDEAE, tribe EAE, subtribe INAE. Then genus, and below the genus categories, they are not having specific endings. It's freedom to you, that whatever you want to give the name to that particular plant, and there is no specific rules regarding the specific ending of the categories. So these are the certain specific endings, and on that basis, for example, family ACEA, on that basis, the name has been on the basis of Aster genus, and the name is given to the Asteraceae family. For example, Araceae family, Liliaceae family, then Nymphaeaceae family, Ranunculaceae family, Magnoliaceae family. So specific endings is always and always ACEA. So whatever the ACE ending is there, that name should be of a family. Where the ALES is there, that name should be of a order. For example, Asterales, Malvales. So these are the specific ending of a order. So these are the certain specific endings, how the specific endings are there. Same is there. But there are certain families are there which are not having specific endings within them. I'm not getting your point, sir. So type is used in bacteria and viruses. I think.
Yes, type, subtype, that is also used sometimes.
Actually, according to ICN, if you want to just classify the organisms in subclasses, you might be given any category as a subcategory. Means if you want subkingdom, if you want phylum, means there are certain homogeneous families are there. For example, Asteraceae family, it is so huge family. Poaceae family, so huge family. So in that particular families, genus are again divided into subgenera. So then species are divided into subspecies likewise. But it is not mostly in certain. There are certain monotypic families are there. Means only single genus and single species are there. So in that particular case, you doesn't need to create such sub categories within that particular aspect. So it is decided by the author who has classified the plants, all these parameters, right? Now, there are certain alternative names are there. So for example, certain families, they are having the older names, and certain families, they are having the new names. Say for example, Umbelliferae family, the name was older name on the basis of umbel type of inflorescence. But it is not accordance with the rules, because there are two rules are applied here, that the name should be, that is second principle is applied here. The name should be on the basis of name of a genus, and according to this rank of taxa, it should be having specific ending ACEAE. Means Umbelliferae, the name has been given on the basis of umbel type of inflorescence. So it is not on the basis of genus. So on the basis of a PM, it is given and a specific ending, so that the name has been given to this family as a PAC. Likewise, PAMI is converted into on the basis of Areca genus, Arecaceae. Composite family is converted into Asteraceae on the basis of type genus Aster. Cruciferae is converted into Brassicaceae on the basis of type genus Brassica. Then Gutiferae is converted into Classiaceae. Leguminaceae has been converted into Fabaceae. Labiate is converted into Lamiaceae, and Gramine family has been converted into Poaceae. So these are the alternative names. These are the new names, and these are the older names. So you have to also remember these older and new names, because most of the times the question will be also asked in examination, which is the new name of this family or older name for this family. Say for example, what is the older name of a Poaceae family? What is the new name of a Leguminaceae family? Likewise. So such are there. So these are the 8 families which either these names are changed, because they are not accordance with the rules, and that's why these names has been changed. Now, the second rule of your syllabus is the typification. This typification is also very much important, which is included in a chapter 2nd of a section 1st. Actually, section 2nd, which includes type method or typification, which are coded by the article 7 to 10. The article 1st to 5, they are coded for rank of taxa. Article 6 is coded for status definition. Actually, it is not included in your syllabus, but in your syllabus, typification is included, where article 7 to 10 are there. So you have to remember, typification is coded by article 7 to 10. So let's we start with the this rule, that is typification. So this typification is also commonly called as type method. As you know that this article 7 and principle 2nd is also just like that of this article 7, that application of a name of a taxonomic group is determined by means of a nomenclature type. Means if you want to give a name to any particular taxa, you the name has always and always on the basis of nomenclature type. Say for example, this is very important, but it is so confusing, because you have to remember there are various types of nomenclature type, and these are very difficult to remember. So I am just teach you in a say very simple language. So when if you might be known about the botanical excursions, I think because of the this pandemic, you might not goes for botanical excursion or botanical tour. But for botany student, you should go for the botanical excursion or botanical tours. And the purpose of these botanical tours is to study the plants at a field level. So if you visit any particular forest areas, you have to go there, you have to collect the plants and study them properly. So there might be a chances that you might find out certain new plants there. So if, for example, if you visited to Boker forest or Kinwat forest, or your Hingoli nearby, any forest area is there, and if you visited that particular forest areas, and you might be got a new plant species which is not recorded elsewhere in any local flora, in regional flora, state flora, or a country flora. So naturally it confirm that this plant is new plant. So what you have to do, when we are going for the excursion or study tour, we maintain the field diary. We collected the plant specimen in a multiple numbers. Say for example, along with your teacher, you visited to a particular forest areas. You just study plant first. Your teacher noted down all the characters of plant first, then plant second, plant 7, plant 8, plant 9, plant 10. And it is considered as plant 10 is a new plant, which is not seen by you, neither by your teacher. It is not present in any flora, which is local, regional, country, state, or whatever else you might be there. So you have to collect that particular herbarium specimen of that particular plant from that locality. And these herbarium specimen, they are acting as a nomenclature type, because you have to given the name of that particular plants on the basis of that herbarium specimen. So this herbarium specimen is acting as a nomenclature type. So what is meant by nomenclature type? The application of a name of a taxa at higher rank is also determined by means of a type when the names are from a generic name. Actually, the nomenclature type is a specimen, all illustration, means any herbarium specimen, all illustration, any photograph, any figure, or any diagram which is a validly published name of a taxon is permanently attached. So if you want to give a name to that new plant, you should submit that herbarium specimen to the Kew Botanical Garden, and so that the name should be attached permanently, that particular herbarium specimen. So that herbarium specimen which is submitted there along with the name is acting as a nomenclature type. So nomenclature type is nothing but a herbarium specimen or illustration to which name is permanently attached. So it's acting as a standard for the solving taxonomic problems. So it is very important for the genus and name of a species, because the name, they are directly involved within this particular aspect, that if any plant you have collected, the names are included, genus name and species name. But what about the family? So in that case, the name of a family should be on the basis of name of a genera. This is the important rule which is coded by the Article 7. Again, the name of a taxa above the level of species, section, genus, tribe, family, etc. based on the name of a immediate next lower taxa on which the groups are originally based. For example, Lamiaceae family is based on genus Lamium. Orchidaceae family is based on the genus Orchis. So these are the important rules which are governed with the nomenclature type. Now we are seeing the different kinds of a nomenclature type. That is holotype, isotype, syntype, lectotype, neotype, paratype, and topotype. These are the different kinds of a nomenclature type. So what are the different kinds of a nomenclature type? Again, these types, they are also very difficult to remember. They are also very difficult to understand. But just see by one. So firstly, the holotype. Actually, the holotype is the original validating description given by original author is based on the holotype. Say, for example, I am given you an example that you have visited to any particular forest area and you come to know that that 10 number plant is acting as a, or this 10 number plant is a new plant, and which is not identified yet. So that's why you have collected 5 different specimens of that particular plant. Say, for example, 10A, 10B, 10C, 10D, and 10E, right? Out of which you have collected, you just brought them into laboratory, you have pressed them and make a herbarium seeds, and you decided that 10A specimen is a very good specimen. No doubt, all the specimens, they are of a same plant. But if you use the 10A specimen for your description, because you have to describe that plant, and after that description you have to name that particular plant. So for the your description, you have to choose any particular specimen. Either you have to choose 10B, either you have to choose 10C, either you have to 10D. But whatever the original author choose the herbarium specimen for the original description, it is acting as a holotype. So in this case, if you, for example, if you use 10A for a validating description and the name is attached to that particular validating description, means 10A, it is commonly called as holotype. So holotype is nothing but a original validating description given by original author is based on a holotype. So whatever the herbarium specimen which is deposited in a Kew Botanical Garden along with the original validating description, that herbarium specimen is commonly called as holotype. So holotype, it is actually a original validating description given by original author is based on a holotype. So holotype should be designated. So if you want to give a name to any particular plant, without holotype, you cannot give the name. So holotype is very much important because holotype is acting as a standard for that particular name of a particular taxon. So the name of a new taxon is valid only when the type of the name is mentioned after 1st January 1990. And all these rules are there, but you have to remember only one thing, that holotype is nothing but the original validating description given by the original author is based on the holotype. The question will be also asked in examination that what is the holotype? Holotype is nothing but a original validating description given by original author. Then, so out of these 5 plant specimen of a same plant, means field number 10, you have collected 5 different plants, 10A, 10B, 10C, 10D, 10E. So out of which single plant you have used for the validating description, and that is acting as a holotype. So whatever the remaining of
Sir, I think your sound is not coming.
Sir, you are not audible. Sir.
okay. Ata?
Yeah, you are audible now.
Okay. So here, isotype is nothing but a duplicate of holotype and are called as isotypes. Actually, the fragments from the same plant from which the holotype is made or plant with the same field number are called as isotype. So for example, in this case, 10B, 10C, 10D, 10E, except holotype, all other specimen of a same field number collected by the original author from the same locality, from the same time, and from the same place, they are acting as a isotype. So in simple language, isotypes are nothing but a duplicates of holotype. You have to remember only this word. Isotypes are nothing but a duplicates of the holotype which are collected at the same time from the same place. Then third, it is a syntype. The syntype is the specimen which is the basis of a new taxon when no holotype is designated by author is known as syntype. Say for example, before deciding the holotype, before describing that particular 10A plant, all plants collected by the author from any particular locality or different locality, say for example, same plant means 10A, 10B, 10C, 10D, 10E. These are 5 plants, they are collected from same locality. I am going to another locality, another forest, and I have also find certain same plant specimens there and also collected from that particular locality, but with different field numbers. But all these plants of a same plant, and same plants, but of a different field numbers. But we have not before deciding the holotype, all the specimens from the same which are collected by the same author, either from the same locality, either from the different locality, either from the same collector, either from the different authors, but they are of a same plant or a same specimen, they are commonly called as syntype. Means before deciding the holotype, whatever the specimens are utilized for the new taxon are commonly called as syntypes. Means these are the collective herbarium specimen. Before deciding the holotype, all the herbarium specimens, they are commonly called as syntypes. Say for example here, if we are collected 5 specimens and we just brought them into laboratory, and we have to decide which would be the holotype. Before that, all these 5 specimens, they are commonly called as scene type. Means before deciding the holotype, all the herbaceous specimens, they are collected from the locality, either from the same locality, either from the different locality, either from by the same author, either by the different author. But if anyone want to give or submit a nomenclature type for naming a plant, all the herbaceous specimens which are uh, uh, just for the suggestion, just for the identification, they are used. They are commonly called as scene types. They are simply called as scene types. So here, up to this condition, we are dealing here with the 3 types. Holotype means the specimen on which original validating description is based is called as holotype. Means the actual name of a plant is based on the holotype. Say for example, Mangifera indica, this name is mainly based on holotype. Then whatever the duplicates of holotypes are commonly called as isotype, and collectively all the specimens, they are collected by the author and used for the nomenclature purpose. They are commonly called as scene types. So these are the 3 different types. Then paratypes. You know that there are certain plants which are monocarpic in nature. Monocarpic means they flower once in their life cycle. They fruit once in their life cycle, and after fruiting they will get died. Means certain plants, they need 50 years, 60 years, 70 years, 100 years for the flowering. So up to that condition, our lifespan is not so much with the lifespan of that particular plant. So naturally, we have to collect that herbaceous specimen. Or certain plants, they might be, for example, Butea monosperma. For example, when you collect that particular plants in a vegetative state, it has all the vegetative characters, but while in a flowering, leaves there fall down. Means Butea monosperma, pearls. When the flowers are arranged, all the flowers, they are not be there. Means only flowers are there. So for that purpose, we have to submit that nomenclature type in a different nomenclature type. Say for example, if the specimen or nomenclature type is attached as a supplement to the holotype. Means if, for example, if you go into the forest areas and you have identified any particular plant which is new one, and you have described in that plant and considered as holotype, and your name has been given. But after some times, after 2 years, 3 years, 4 years, and any particular character which is not submitted as a nomenclature type, while firstly you have described in that particular plant, and for example, fruit is not attached with your first specimen or in a holotype, and if you find out fruit specimen after 2 years, 3 years, 10 years, 15 years, and you want to submit that fruit specimen or nomenclature type within that herbarium specimen attached to the holotype, such is commonly called as paratype. So paratype is nothing but a supplement to the holotype. Means this paratype is actually a specimen other than holotype or isotype is called as paratype.
Nagarkar sir, loud is not clear.
Yes, sir. I think he going to lose the network connection. There is interruption of internet connection, maybe.
हॅलो,
Yes, sir. Yes.
येतोय सर आवाज?
हा, आता येतोय. नेटवर्क कनेक्शन बहुतेक तुमचं जात आहे.
हा लाईटचा प्रॉब्लेम आहे, मध्ये लाईट जाते.
Yes, yes. Okay.
Okay. So such type of specimen which is attached as a supplement to the holotype, it is commonly called as paratype. Then lectotype, actually it is a type chosen to serve as a holotype when neither an earlier designated holotype was lost or destroyed, or holotype was never designated, or from the isotype, paratype, syntype is specimen is chosen by specialist to serve as a type. Means for example, if anybody any author who has cited the herbarium specimen as a holotype, he has given the name on that basis, but that because of certain reason that holotype is lost, it might be get destroyed. So the latter worker would choose the another holotype, but from the same collection of a original author. It is commonly called as lectotype. So the selected from original material, but selected by subsequent author, means that original author is no more there, and his herbarium specimen or holotype is also lost, but their herbarium collection is there, and from that original author's herbarium collection, one herbarium specimen is acting as a nomenclature type. So, but it is chosen by the subsequent author. It is commonly called as lectotype. So, lectotype is nothing but a when holotype is lost, the nomenclature type is chosen by another author or subsequent author by from the original author's collection. It is commonly called as lectotype. So, for example, this Ceropegia angustifolia, which is a lectotype, which is given by Kamble and Addo. Actually, this name has first time given by the wheat, but the original holotype was lost, so that Addo sir and Kamble has given this lectotype here. Then neotype, if holotype, isotype, paratype, or syntypes are lost, means original author's collection totally lost or destroyed. The neotype is selected from other specimen to serve as a type. Means in that particular case, if any author or the same author, they are collected from different type localities, different specimen or different collection of herbarium specimen, but the specimen or the plant is same. In such case, it is commonly called neotype. Neotype means new specimen is submitted as a nomenclature type. So this some taxonomies it is called as a standard specimen. So this is a specimen selected or served as a nomenclature type if no original material is exist, or it may be missing, selected by subsequent author. So this is commonly called as neotype. And the last one is a topotype, where no original type material is available and the specimen is collected from the type locality. It is commonly called as topotype. So these are the different 7 types of a type method. So just we remember all these, just overlook all these type. Here, holotype is nothing but a nomenclature type on which the original validating description is based. Isotype is the duplicates of holotype. Paratype is any other specimen described along with the holotype as a supplement. It is commonly called as paratype. Syntype, any one of the 2 or more specimens cited by the author when there is no holotype designated. In that case, it is commonly called as syntype. Lectotype, where original material or holotype is lost. In that case, the nomenclature type is selected from the original author collection by subsequent author, is called as lectotype. Neotype means totally new nomenclature type or herbarium specimen is selected by subsequent author as a nomenclature type, is called as neotype. And topotype, the nomenclature type is collected from the type locality. It is commonly called as topotype. So these are the different types of kinds of nomenclature types. Then the last article, which is a author citation. This major rule, which is included in your syllabus, is the author citation, which is coded by article 46 to 50. So the name of a plant cannot be complete without an author's name. You might be visited to botanical gardens and you might be seen certain nameplates of plants. For example, Mangifera indica YEL. So this YEL is stand for the name of an author. So the author's name is in abbreviated form. So if you want to write the name of any particular plant, it should be always and always attached with the name of an author who has first time discovered that particular plant. So there are certain rules which are related with the author citation, how to cite that name of an author. These are certain rules are there. Say for example, it is necessary to cite the name of an author who first validly published the name. For example, hibiscus, YEL. Either it may be a unitary name, binary name, trinary name, but you should given the name of an author. Then according to author, Article 49, taxon of a lower rank is altered the name of a second author has been given in the parenthesis. Say, for example, Citrus aureum, variety grandis, L. When raised to a rank of a species, it becomes Citrus grandis. L is the first author, but actually Osbeck made this change, and that's why the first author name is in a parenthesis, in a bracket, and second author who made the change is alter that particular change, and that's why his name is also be there. So it is also commonly called as double citation. Then when subdivision, likewise, if taxa is altered, either the subdivision or the family or any other particular case, such names should be there as a double citation. Then use of EX means the name of two authors are linked by EX when the first author proposed a name but was validly published only by second author. Means, say for example, there are certain authors are there who publish that particular name, but it is before N.E.S, and that author is no more. But if second author is there and who has published that name accordance with the rules of ICBN, means validly published there, and so that both authors has given credit there, and the second author, the first author failing to satisfy all requirement of the code, and that's why Sirius Cormuta Wall X Royal means EX is mainly related for the second author who has made that plant or published that name of a plant validly. So for that purpose, EX, this use is there. Then use of ET. When two or more authors publish a new species, their name are linked by the ET AL or ET. We use most commonly. Say for example, Delphinium viscosum is published by jointly by two authors, who key up ET Thompson. Means these two scientists, they identify this plant jointly and publish this plant jointly, and that's why ET means and. Then using IN when first author publish a new species or name in publication of another author in use. For example, Carex casmirensis, Clark in Hook means Clark, scientist who has first time given this name, but he has published in the book Flora of British India of a hooker, and that's why such naming is there. Then two authors are linked using emend. A person making amendment or corrections in diagnostics or circumscription of a taxa without altering the type, emend will be there. Say for example, Phyllanthus, Lin emend Mull means this Muller was the scientist who has altered the circumscription or any correction within diagnosis of or a circumscription of that particular case. Then in the citation of infraspecific taxa, both authorities are called as Acacia nilotica, Dale species indica, Benth, and in case of autonym, infraspecific epithet does not bear author's name since it is based on the same type or as a species. For example, Acacia nilotica Nil, Dale species nilotica. So these are the certain rules are there. You have to remember all these rules, and the question will be asked in examination, particularly MCQ type of question will be asked in where actually the EX is used, where actually the ET is used, where actually IN is used, emend is used in a nomenclature of or author citation. So such these are the rules of author citation. So I think it is sufficient for today. So if you have any difficulties, please ask. Yes.
Very nice, sir.
I think
it is
very lengthy, very
lengthy topic also, and such a very difficult topic belongs to plant taxonomy, ICN. I think students have been well documented with this. Sir has been elaborated lots of things, starting from the botanical names, how the importance of the names are there, how the ICBN has been changed to ICN also. That I also don't know how this ICBN has been changed to ICN. That is a change in the Melbourne Congress in 2011. So then after Dr. V.R.Marathe sir has been given a very vast history of ICBN. Very nice, sir. And then after he has been well elaborated the principles and rules of ICN particularly. And then in very easy figure, very easy language, he has been elaborated on a typification type. I know very well, sir. Yeah. तुम्हाला माहिती आहे, the students do not get this typification. That is out of generally getting to be out of mind most of the time. Sir, that is very difficult topic, and that you have given a very nice elaboration, very in simple, easy, and figures. Very nice presentation also you have prepared, PowerPoint presentation. That is very good. One thing I want to know that generally type, subtype, generally use in case of bacteria or maybe viruses, just like type H1N1 or suppose any name. Is this case related with the plant?
Actually, type and nomenclature type is different one.
No. I just want to ask type, subtype, just like that. Type 1, type H1, H1N1, just like we named virus.
Yeah. That is, they are using virus and bacteria, but they are not using here in plant.
Yes. Not used. Sir, yes, I welcome Dr. Solanki sir here, in charge principal, Adarsh Mahila College, to say few words on this occasion. Solanki sir.
I have tried my level best, but this topic is so vast and very difficult to understand.
Yes, sir. We know very well. I am one thing I have to say to audience that I am also the student of Dr. V.R.Marathe sir. He has been taught me at the university level. Yes.
Dr. Sir, I am asking one question to Vishal sir.
Yes. Welcome, sir. Please welcome. Yes,
am I audible, Vishal sir?
Yes, sir.
Yes, sir. Go ahead, sir.
You had delivered a very nice lecture, no doubt about that. You had covered all the basic points in ICN and so on, and it was very nice, absolutely. Students, I hope that students cleared all the points as per the exam point of view and details also, basic points. And I want that, is there any resume or any descriptive pages or publications regarding the ICN in 2011? And one more question is that, as we are told previously, it is a Paris code, and we may call it as Melbourne code.
Yeah. Actually, sir, every 5 to 6 years after International Botanical Congress, they held their meeting as an International Botanical Congress, and in that meetings they are modified, change or altered the names, or regulate or rules are also be get altered. And that meeting minutes, they are published as a code, means whatever the decisions which are taken as a the meeting which is held at Paris, it is published as a Paris code. Likewise, Melbourne code, likewise Shenzhen code. All these codes are there, and they are readily available in on the internet. That Melbourne code is also available on the internet. Shenzhen code is also available on the internet. So if you want in detail, you just visit it to IAPT site, International Association of Plant Taxonomy. In that site, you might get all the links there.
Okay. Good. Thank you, sir.
Okay. Not only that, just because of the type constant, all the codes and their regulations and all these there be there. Say for example, first is the Paris code, where Linnaeus rules and nomenclature, rule of priority, author citation is decided within the Paris code. In Rochester Code in 1892, type as a scientific and fundamental basis, rules of priority, acceptability of toponyms are decided within Rochester Code. In Vienna Code in 1905, that is Latin diagnosis, toponyms were not accepted and date of publication was alone accepted for the priority. Such decisions were made. In Leningrad Code, whatever today's code outline is there, that is principles, rules, and recommendations, which are divided into 3 different divisions, which are coded by Leningrad Code in 1975. Then likewise Shenzhen कोड आता जो नवीन कोड आहे सर Shenzhenचा कोड in that Asclepiadaceae family is merged into the Apocynaceae family. So today there is no Asclepiadaceae family. There is it is included in the Apocynaceae family. Likewise Tectona grandis. Tectona grandis, we know that the family of Tectona grandis is Verbenaceae family. But actually, according to this code, it is not included in Verbenaceae. It is included within the Lamiaceae family now. Lamiaceae. So such changes they might be get changed. So such changes or certain rules, regulations, certain difficulties, corrections will be made in every after 5 to 6 years.
There should be such a position should be that we are the members of Indian Association of Angiosperm Taxonomy. Our mail is was also there. So member should add such type of the new additions in our mail also. We may suggest to them.
Yes, sir. Yes, sir.
A.K. Pandey sir and so on, such type of the members who are president, secretary, and so on. So we should be update.
Yeah, yes, yes.
If such type of the new additions are inserted, in our mail and so on.
Yes.
Okay.
But, yes. Sir.
Thank you, sir.
Okay, sir.
So with this, I am going to turn to last part of the session. Dr. Solanke, sir, are you online? Dr. Solanke, sir? Okay. With this, I am expressing here sincere thanks. Saying a thanks is very limited word to Dr. V.R.Marathe, sir. Actually, he has been elaborated very nicely in very simple language, the topic, principles, ICN rules and principles. So on this occasion, I am very much thankful to him that he has been given a very nice lecture, fruitful lecture to the students. I hope that students are benefited and teachers are also benefited with this lecture. I am thankful to in-charge principal Dr. A.R. Lathi sir, Adarsh Mahavidyalaya. Yes. Welcome, sir.
I am audible to you.
Yes.
Sir.
Yes. Only for 1 minute.
Yes, sir. Yes.
Dr. V.R.Marathe, sir.
Namaskar, sir.
Namaskar. On behalf of Department of Botany, N.E.S College, Hingoli, I am first of all thankful to you as you have given a valuable time to our student and our teachers. You elaborate the topic very nicely, and it was so you call it the beneficial as well as the informative for us as well as our students. And I hope you will deliver such type of lectures in the future also, and you will give us such type of opportunity to us one, as well as our faculty member of SRT MU Nanded. And as at the beginning of the speech, as you said, why the students fear about taxonomy? It is a fact one, because of that the names, that Latin names, they are confusing within that, and it is actually you call it that not easy to remember the names of that, and that's why actually there is a wide scope to taxonomy, plant taxonomy, but there are several drawbacks and due to that one. So again, thanks to you. Thank you very much.
Thank you, sir. Thank you.
Thank you, sir. Thank you very much for your nice words. Your words are always again energetic to us and giving us the energy to organize such events. I am again thankful to Dr. Solanke sir, in charge principal, Adarsh Mahila College. I am also thankful to Dr. Deshmukh sir, who is also present with this session at the end. Then I am also thankful to Dr. Anand Wagmare sir, Pulate sir, and those who teachers have been joined directly, indirectly by means of on YouTube live also. I am also thankful to them. And lastly, I am thankful to students, dear students, who have been joined this session. With this, I hereby declare that the session is over. Thank you, sir. Thank you, Marathe sir.
Oh, thank you, sir.
छान झालं सर.
बेस्ट झालं, बेस्ट.
बेस्ट झालं, बेस्ट.
हो, आणि बराच वेळ घेतलं, जवळपास 1-2 तास, जवळपास 2 तास. नाही, चांगलं म्हणजे ते एकदम MSc लेवलच्या स्टुडंटसाठी घेतलं, हे केल्यासारखं. हो हो हो, म्हणूनच म्हणलं मी अगोदरच नगरकर सरांना म्हणलं